Welcome to loving long division. So you can divide polynomials using steps that are similar to the long division steps that you use to divide whole numbers with. When you try to factor a polynomial, you're trying to find the divisor of the polynomial that gives a quotient being the other factor and remainder 0. This suggests that being able to divide one polynomial by another could help you factor polynomials. Numerical long division and polynomial long division are similar.
Problem 1. In any polynomial long division problem, your first step will be write the polynomial or term you are dividing by outside of the symbol and the term that you were dividing inside of the symbol, which in this case it happens to be 4x squared plus 23x minus 16 divided by x plus 5. Our first step would be to find a term that would multiply x to equal 4x squared to cancel out that term, and that would be 4x. You then subtract 4x squared plus 23x from 4x squared plus 20x, and 4x squared ends up being canceled. 4x is brought up to become part of your answer in place above the x. Your answer for the subtraction problem is 3x, and you would bring down the minus 16 to become 3x minus 16. You would then multiply x plus 5 by 3, move the 3 up to the spot in the answer, so you would get 3x plus 15, and you would subtract this as well. So your answer there would be negative 31, which is not 0, so you would have an answer of 4x plus 3, remainder negative 31.
Starting off, you're going to write your dividing symbol, and on the outside of it, you're going to write the term that you are dividing by, and then on the inside of it, you're going to write the polynomial that you are dividing. So the goal is to eliminate each polynomial starting with the highest. So you put what you're dividing by in parentheses, and you need to find something that will multiply with what you're dividing by to cancel out your terms. So x plus 5 can be multiplied with x cubed to create an x cubed plus 5x squared, which cancels out the x cubed and leaves you with a 4x squared plus 23x when you use subtraction to see the difference. So once you figure out you're left with a 4x squared, the 23x comes from your polynomials above. You bring down the next polynomial there is, and then you repeat the same process. So each term that you use to multiply with what you're dividing by goes up at the top to form your answer. Repeat these steps until there are no more terms to bring down, and then you will have your answer at the top. Our answer for this problem is x squared plus 4x plus 3.
The terms of these equations must follow in a direct descending order, so if an x does not exist, a 0 must be inserted. Checking the factors of polynomial long division is essentially the same as just solving a problem. The setup is exactly the same, except the factor that you are checking is what the polynomial is being divided by. In this case, it would be x squared plus 0x, since that x did not exist, there must be a 0, plus 1, and that is dividing 3x to the fourth, minus 4x to the third, plus 12x squared, plus 0x, since the x did not exist, and plus 5. First, we must follow the same steps, which would be multiplying what you were dividing by 3x squared to make it equal 3x to the fourth to cancel that term out, and then subtract everything. The 3x squared would then be moved in the appropriate spot for the answer. 3x to the fourth becomes canceled. You would subtract everything and then bring down the 0x. And then you would repeat the same step by multiplying that problem by negative 4x, so that it would match up to negative 4x to the third to cancel it out. And then you would follow the same steps until you get to your answer to whether or not x squared plus 0x plus 1 would be a factor. Finally, you would subtract this last problem, and if your answer is 0, x squared plus 1 would be a factor. But in this case, the answer is not 0 and there is a remainder, meaning that x squared plus 1 is not a factor of this polynomial problem.
Oh my god. Continue.
I know, they're everywhere.
I should have smacked it. Okay.
The hell are you?
Oh my god. Mosquito.
I don't want malaria today.
Not today. Okay,
Blooper
continue.
reel, smacking at bugs.